A very good morning to Dr. Najwa. My name is Awei, Gravimetric number DW210027. Today I'm going to present the introductions. This experiment is about using the gravimetric analysis to determine the chloride ion in the soluble sample. So what is gravimetric analysis? Gravimetric analysis is the most common quantitative analysis method to determine the amount of the substance present in the aqueous solution sample. This method includes dissolving the sample to be analyzed, reacting the sample to form a precipitate of the known components, separating the precipitate during the filtration, and weighing the drying product. There are two objectives for the experiment. For the first one is to apply the gravimetric analysis to quantitatively determine the chloride contents, and the second is to understand the concept of stoichiometry. Next, I will briefly explain about the procedure for the experiments. And during heating, 0.2 molar of the silver nitrate solutions (AgNO3) was periodically slowly added to the sodium chloride and HCl sample solutions that contain the chloride ions, and then acidified with 0.5% 6 mol of the nitric acid (HNO3). At the same time, the mixture was continuously stirred to form the precipitate of the silver chloride (AgCl). When the reaction is complete, it can be observed that the solution changed from the cloudy to a clear color. A translucent liquid above the AgCl precipitate is called as supernatant solution. Afterward, the AgCl precipitate was then filtered out using a filter funnel with a very small pore filtering bed and washed with the dilute nitric acid. The function of the nitric acid as a wastewater aids the coagulation by providing a high electrolyte concentrations and preventing the precipitation. The precipitation at here means that the conversion of the relatively large particle of the possible precipitates into a colloid suspension and cause it to penetrate through the filtering bed. Besides that, the acidity conditions also eliminate the interference of the weak acid and ion, such as the carbonate and sulfide. Then, the funnel filled with its contents was warped with the aluminum foil and then died in the oven at 120 degrees C for 19 minutes. During that, the acid is volatilized. Before weighing, the precipitate was cooled in the desiccator to prevent the exposure to the moisture in the atmosphere. Last but not least, to achieve the objective 2, the mass of the chloride is calculated by using the stoichiometric concept, where the ratio of the silver chloride to the chloride is 1:1. So to obtain the mass of the chloride, we calculate by using the mass of the AgCl obtained multiplied with the molar mass of the chloride and then divided by the molar mass of the AgCl. So we will obtain the mass of the chloride for the first run and the second run. Thank you, that's all from me.
Next, the material and apparatus that have been used for this experiment is 6 molar of nitric acid, 0.2 molar of silver nitrate, sodium chloride, and filter funnel.
Okay, so here's the result for the experiment. We have the mass of argon chloride for run 1 and run 2, and the average by adding both of them and divided by 2, so we got 0.3047. And then we have mass of chloride and the average of 0.0754, and then we calculated the percentage of chloride, and we got the average of 14.6427, and then we have initial temperature in degrees Celsius, and we got the average of 28.5 degrees Celsius, and then we have the final temperature, which is 60 degrees Celsius, and then we have time of precipitation form. For the average is 54.
So in this experiment, we use the gravimetric vector to calculate the mass of the analyte. So the formula is the molar mass of analyte will divide with the molar mass of the precipitate. So here the 35.453 gram per mole is the molar mass of the chloride, and the 143.32 is the molar mass for the argentum chloride. So the GF that we get is 0.247. So for calculate the mass of chlorine, is the formula is the mass of precipitated, which is the argentum chloride, times with the GF. So in the round one that we get, the mass of the chloride is 0.0767 gram, and in the rounds two, the mass of chloride that we get is 0.047. So here is the calculation for calculate the percentage of the analyte. The formula that we use is a mass of the analyte will divide with the mass of sample and time with 100. So in round one, the percentage of analyte that we get is 40.922%, and the round two, similar with the round one, which is 40.363% of the chlorine.
Hi everyone, I'm Lim Boon Siang. Now I will continue with our discussion of this lab report. So, based on our finding, only an average of 14.6427% of chlorine precipitate detected, which means another 86% are still in the solution that filter out. So, based on our identification, the percent error is about 24.1435%. So the percentage error is far from the 100%, which means the accurately correct and is unacceptable. So the experiment can be identified as an failure experience. So in this experiment, we only have two samples running in the progress. So because of that, the statistical analysis are not suitable to be applied because we cannot identify any outliers or any exception in the data we collected.
When we discussed about the color of argentum chloride, the left picture show that is shown in the purple color. However, in our reference state that the color of crystal should be white. But is an important which it show the color of the argentum chloride show the argentum already reduced to its original site. So it will gone out with a purplish illumination in our experimental. It is an important step that we need to wait before the light shine because it will absorb the UV light to reduce into the purplish color. So the type of illumination of argentum chloride are being classified as a fluorescent, which it will absorb the light and released in a public violet color radiation.
As the experiment the result are mainly show in failure, so we need to identify the main variable that affect our result are not accurately, and there are a lot of chlorine left in the solution. So the main variable will be the volume of argentum nitrate droplet, because in this experiment the method or the recorder does not record the argentum nitrate, which the important precipitating agent. Their volume uses in precipitation are not counted. So we cannot identify is the argentum nitrate enough to precipitate, or there are many leftover ion inside the water. So other random variable can be the temperature or the time, but the major variable will be the volume of argentum nitrate. As for the limitation in this experiment, we know that the method are relied on the reactivity of metal ion. The There are two reactivity and metal ion. One is the sodium and another is the argentum. So the reactivity are based on the argentum nitrate, which it has the argentum ion. The reactivity will affect how the precipitation come up, because the argentum nitrate need to react with chlorine ion. So in the low reactivity condition, the precipitation and reaction will be slow and will unclear. It's important that we know that the main limitation in this reaction.
So now I will be continue to explain about the discussion. The precaution steps that could be taken are accurately measure the inertia and final volume of silver nitrate solution, and use light scattering to identify the endpoint of precipitation. Next, the improvement that should be taken is we can use the spectroscopy to identify the low reactivity method. Besides, other precipitating agent may be used as replacement of the precious metal.
Conclusion for this experiment is gravimetric analysis can used to determine the concentration of unknown chloride solution or the percentage by mass of an unknown chloride salt. The mass of chloride we got in round 1 is 0.0767 gram, whereas the mass of chloride in round 2 is 0.074 gram. The stoichiometry is a section of chemistry that involves using relationship between reactant and or products in a chemical reaction to determine desired quantitative data. The equation for this experiment is stated as below, which is silver nitrate solution react with sodium chloride solution, produce silver chloride solid and sodium nitrate solution.
Hi, my name is Ganshimin with metric number DW210022. So I will present for the question lab for this experiment. So the first question is determine the coefficient of variation of the data. So the formula for the coefficient of variation is standard deviation divided by mean. So the mean we get in this experiment is 0.3048, and the standard deviation we get is 0.0077. So the answer we get for the coefficient of variation is 0.0253. So the lowest value of coefficient of variation, the more precise of our result. So the second question is determine the gravimetric factor. So for the formula for the gravimetric factor is formula weight of analyte divided by formula weight of precipitate. So the formula weight for analyte is 35.453 gram per mole, and the formula weight of precipitate is 143.32 gram per mole. So the gravimetric factor we get is 0.247. So the third question is determine the percentage of chloride in NaCl. So the formula for the percentage of chloride is weight of AgCl precipitate weight times gravimetric factor times 100. So for the percentage of chloride for run 1 is 7.67%, and for run 2 is 7.40%. So that's all from me. Thank you.